Hi, so this is my first problem which I'm recording, and the name of this problem is best time to buy and sell a stock. Fifth, so basically we are given an array price is I, which indicates the price of the stock on the ith day, and also we are given an integer k. So what does k means? K means that we are only allowed to make at most k transactions. And what is a transaction? So there are two types of transactions given here. First can be a normal transaction on which we buy a stock on ith day and we sell it on J, where I is less than J, of course, because we in a normal transaction we buy and then we sell, and our profit is the difference of both. I mean, the difference of the price on jth day mm, and minus the price of on the ith day, and a short selling transaction. So what a short selling mean in stock market is that we sell first and then we buy. So if we know that a stock is going to crash or its value is going to decrease, then we first sell it and then we buy it. So there are some technicalities in stock market that we have to borrow it, and there are some borrowing fees. And on the borrowed stock, the stock we have borrowed, we will sell it, and then if it crashes, we will buy it on lesser price, and then we will give it back. So that how short selling works in the stock market. So here also we can sell the stock on ith day where I is less than j, and then we can sell it on later on the jth day. And the difference of this, which is the price at ith day minus the price at jth day, is our profit. So and there is also a note that we must complete each transaction before starting another. Means it's not like we have started a transaction right now and before like there's a normal transaction and before selling we can again buy or we can short sell. We must close the transaction at a time. Either there is no transaction going on or there is one transaction going on. And additionally, you can't buy sell on the same day you are selling or buying back as part of the previous transaction. Okay, we will look into this thing as well when we will look into the examples. So we need to return the maximum profit if we make at most k transactions. So let's see an example. Like here is an example 17982, and we can make at most k transactions. So the optimal will be if we buy on the first day with by paying a price of $1, and then we sell it on the ninth day, right? And so this is a profit of $8. I mean not on the ninth day, but the third day on the price of $9. So we made I think we made $8 here. But now we cannot start our short selling transaction on the third day itself. We have to move to the fourth day on the index 3, and then we can make the short selling transaction. If we would have made the short selling transaction here, then we would have made the and sold it on the last day. We would have made the profit of $7. So 8 plus 7, 15 would be the answer. But as it is mentioned here, that we cannot start the transaction on the same day. We have to wait for the next day or any other day or any other upcoming day. So we made a short selling transaction on these 2 days, and so 8 plus 6 we got 14. 14 as our answer. Similarly here, it is also given that uh, we can make at most three transactions. So we made one transaction on the first day and sold it on day two, which gave us a profit of 7. So this is the optimal answer. Like the maximum profit we can make out of it is $36. So how do we get to it? Like so this seems to be a DP problem because we can see that the constraints here are 10 to the power 3 for the length of the array, and k is also of the order 10 to the power 3, or at max 500 actually. So what we can look here is that while we are uh, while we are making decisions, we are at most at three cases. We are exactly having three cases. That is, there is no current transaction is going on, which means that we haven't bought any share which is due to be sold, or no, sorry, and there is no short sold share which is due to be bought. So this is the case one, that there is no transaction going on. Second case is that a buy transaction is going on, which means that in one of the previous days we have bought one share and we haven't sold it yet. And the third case is that we have short sell one share on one of the previous days and it is due to be bought. So these are the three cases, and we can simply make decisions based on these three cases, that either to buy. So in the first case, we can either so in the first case where there is no current transaction going on, we can either buy, we can sell, or we can buy, which will initiate a normal transaction. We can short sell, which will initiate a short selling transaction, or we can skip the day and move to the next day, wait for the next day. So in the first case, there are these three choices. On the second day, there is choice. On the second case, where we have already bought, there are two choices, which means that we can skip the day and move to other day, or we can sell it. We can complete the transaction. And similarly, on the third case also, we can either skip the day, as a short selling transaction is already going on. We can skip it and wait for the further days, or we can buy the stock and complete the short selling transaction on the same day. So there are three cases, and in the three cases, we are having some choices. So this is the case of selecting things, and there are repeating sub problems also. So DP would be a well optimized solution for this. So let us see and try out this problem with the memoization technique, which is the bottom to top technique. Let's see the code, and then we will get to know what I was talking about. So here it is. So this is a recursion based DP technique, memorization. We have created a 3D DP array which holds the I index, and which goes from 0 to n minus 1, and also the k values which go from 0 to k, that how many transactions are we have remaining. And also there are three cases, so which case currently we are in right now. So to give the status of that, we have taken another dimension of the DP array with three choices, that is 0, 1, or 2. And what are these 0, 1, and 2? So if it is 0, then there is no open trade, and if it is 1, then a buy trade is going on. If it is 2, then the third case, which is a short selling trade, short selling transaction is going on. So these are the three cases, and for all these three cases, we have written our uh, like possibilities, like what we can do, the choices, and then we have taken the maximum out of these three choices for our to fill our DP array, and then we have returned the uh, element which reads out the maximum profit. And the base cases would be for here, like if we have no transaction remaining, if the transaction goes below zero, then of course we cannot make any profit, we will return zero. And we are iterating over I, which means the indices of the prices array. So if I goes beyond n minus 1, we cannot make, of course we cannot make any profit. And this is the obvious case for a DP problem, that so we have initiated this array by minus 1, like there is negative profit here, because there can be a case. So 0 is the maximum profit that we can make in any problem, right? So we have initiated it with minus 1. Sorry, 0 is the minimum profit that we will make. Sorry. So we have initiated it with minus 1. And so if it is unchanged, then we have to move towards like modifying the DP array. Otherwise, if it is changed, we have the answer for the DP. array of that particular stage of that particular I, K, and status, we will definitely return it and we will not repeat the sub problem. So if so for the case one, when there is no open trade, and if there is no open trade and there are no transactions remaining, right, then we of course have to return zero. We cannot make any transaction and there is no open trade. Of course, we cannot make any profit. Or if we are at the last if we are at the last day and there is no open trade, so of course we cannot open a trade and close a trade on the same day and make profit. If it is the last day, then we cannot make any trade. So we will of course return zero here as well. Now we have made three case. We have to make decision between three things. That is to do nothing on the day, buy or sell. So these are the cases. So this is the buy case. If we are buying, then from our pocket we are reducing money, right? And if we are selling, then we are adding money. So in this problem, this is a key thing to note that while buying these stocks, we are subtracting the amount, and while selling, we are adding the amount, right? So while buying, we subtract the price of the current day, and here we change the I to I plus one, and of course we have made a transaction, so we will change it to K minus one. The status will become to buy. The status will become uh, case two, which is bought. Buy transaction has been initiated, and NDP would remain as it is. Similarly, for the selling thing, here the status will become two because we are now in this case, right? And then the maximum out of it is our answer for that current TP element. For the case two, where the status is equal to one, which means a buy transaction is already going on. So if a buy transaction is already going on, right, and we are on the last day, then of course we have to sell it. When we sell it, we return positive. So we will return prices of the last day, right? And what other choices we have if we are not on the last day? We can either retain it or we can sell it. So do nothing or sell. And these things are self-explanatory that if we are not doing anything, the status remains to be the same. And the status remains to be the same. There is no change in the number of transactions remaining, and we move to the next element. Similarly, if we sell, we move to the next element, and we add prices I to our pocket, and the status becomes to be zero because there is now no open trade going on, and we return the maximum out of these two. And similarly, for the short selling case, you can look here. So this is the first solution that I got upon, and here we just return the DP element which we got out of one of these three cases. And what we are returning in the final answer is our prices, where we are starting from I equal to 0, and we have k transactions in hand, and the status, of course, in the beginning is 0. So yes, this was one problem, and if we can see here, our time complexity would be k into n into 3, so which is basically k into n, and our space complexity will also be same, and this is a memoization approach. So generally, tabulation approach is better than memoization approach in terms of time and space complexity. If we see that this answer is accepted, and but the runtime and memory wise we are lagging behind. So let us move towards another approach which is of the same time and space complexity, but it's a tabulation approach. So it is also important to know that how do we convert our memorization approach to tabulation approach. So first, what we will do, we are having some edge cases here. We will deal with them. We will make the DP array like this, and then we will deal with these test cases. So let's move to the tabulation approach. Just a second. The second one is the tabulation one. And here is the answer, and here is the code for it. Yes. So we have made a 3D array like we made before, very similar to that. I mean, same as that. And then we will handle the edge cases. So if you remember, then on the last element, we were having edge cases in all the cases. For the last element, if we are having if we are having no transaction going on, then we can't do, our profit is zero. We can't do anything. Our profit is zero. If we are having a if we are having a buy transaction going on, then our profit, we have to book profit. We have to sell that stock. And if we are having a short selling transaction going on, then we have to, of course, buy that stock and book profits. So this is the thing which handles those test cases for all k. If or not we are having any transactions in hand, we have to do these things in the last element, because one thing to note is that we are reducing the remaining number of transactions, which is k, once we do the take the first step. Like in a normal transaction, if we are buying, then we are doing k minus minus, right? So even if we don't have any k in hand at the last element, we can certainly say that these are the steps that we are going to do based on the case we are falling into. Now we will run our loop for loops. So this will also be a n into k approach, and in this we will handle k. So we will handle all the three cases inside our for loop. So as we know that we have handled n minus one, and in our sub cases we are, like, if we think about our memorization approach, we were going to I plus one. Like we need I plus one answer to get the answer for I. So here we will move backwards. That's why. So here, as you can see, the I is going to be in decrement, and as we have answer for the last element n minus one, we can start from n minus two. For k, we can start from 0 to last, or it doesn't matter. We can move backward also. So here, what we can see is that as we are having k minus one, like k reduces. If we are in the case one first, then we have to handle the cases of k minus one also. So for these, uh, if we are on the 0th k, there is no transaction, then of course we can't make any transaction. So we will, if no transaction is going on and no transaction is left, which means no k is left, no kk is left, then of course our profit is zero. And if there is some transactions left with us which we can perform, then we can take the maximum out of no transaction, a buy transaction, or a sell transaction. Similarly, for the other two cases, like we have taken these numbers as we have taken in the memoization approach, and we have returned the same thing, 0 k status 0, and this is our final answer. And this is also a n into k approach. But as we can see that we don't need the access to any other ith dp array other than the one which we calculated last. So here we are calculating I. Uh, Here we are calculating I for I plus ones, right? With the use of I plus one. We don't need I plus two or I minus three, right? So we can just replace this array. We can just replace this to a 2D array, to a 2D DP array. Okay, and then we can then we can at least reduce the space complexity, but not the time complexity. So time complexity would be the same, and we can reduce the space complexity to n rather than n into k. Right. So let's move to that approach. Yes, this is the most optimized solution, in which we have made an array of sorry, this time complexity is n into k, and the space complexity is k only, because we don't need the solution for multiple i's. We need solution for just one I. So this becomes our solution. The first edge cases are the same, and then we have of course initiated our I from n minus 2 to 0, and then similarly, as we did before, we have initiated the k, and then we will talk about this. I will tell you that why we have kept this. So we have in the same way we have just modified. We have modified our current array with the elements of our I plus 1, but we are making the modifications in the same array. We are not using any other row or column. We have just used a 2D array. So we are directly modifying. But when we have modified dp kk0, and we require it further in our calculations, right? We require it to either purchase or sell. Then we cannot use these modified ones. We need the original one. So that's why I have written it in the form of I have saved it in X and then using the X here. So it's all the same things we have done for the space optimization. And this was the space optimization approach. And this was the final optimized solution for this problem as well. Thank you very much.